I don't know why we don't hear about these things more, but probably because most of what you see out there on the internet focuses more on what you could eat and should eat or shouldn't eat. It concentrates on exercise regimens, which we will also talk about. But the burn factor, your thermogenic environment, is one of the, if not the most important factors in this business of fat loss. And since I'm a neuroscientist, that's what we're going to talk about. So let's talk about fat utilization. Let's talk about how fat is converted into energy, which is sometimes also called fat burning. What I'd like you to know is that this is a two-part process. Okay? In reality, there are many biochemical steps. And if you log onto the internet or you open up a textbook and you want to learn about fat utilization, you're going to see a lot of chemistry. And I'm happy to go deep into that chemistry if you like, but I think most of you are probably interested in what are the leverage points? Where can you exert control over this process in ways that benefit you? So I'm going to focus mainly on those, okay? This is not to upset the aficionados, and I will put in some nomenclature, but here we go. There's two parts to this process. One is fat mobilization, and the second is fat oxidation or utilization, okay? So the first thing that has to happen for body fat to get burned up or used and reduced is that it has to get mobilized. And that's a process called lipolysis. But I actually don't care if you know the name lipolysis. You just have to move that fat out of the position that it's in. You have to get it out of the fat cells, all right? Fat cells can be visceral around our viscera, our organs, or they can be subcutaneous under our skin. Most people are thinking about subcutaneous fat when they think about fat. So here's the deal. And if you want more detail, great. I'll touch on that in a bit. But basically, stored fat has two parts that are relevant here. It's got the fatty acid part, and that's the part that your body can use. And that's attached to something called glycerol, and they're linked by a backbone. So already probably too much chemistry for both of you. But what you want is you want to break the backbone. So if you just can remember to mobilize fat, you got to break the backbone between glycerol and these fatty acids, okay? That's accomplished by an enzyme called lipase, but you can forget all that if you want. Remember, we're just trying to mobilize fat. So the first step is to get those fatty acids moving around in the bloodstream, to get them out of those fat cells. And then they can travel and be used for energy. And that second part, remember, first part is mobilization. The second part is oxidation, is then those fatty acids, those are potential fuel. They're just potential fuel, but you haven't burned the fat yet. You've just moved it out of your fat cells. They're going to go into cells that can use them for energy. And once they are inside those cells, they're still not burned up. You need to oxidize them. You think oxidation is the burn up part. They need to be moved into the mitochondria, and then they can be converted into ATP, into energy. So just to really zoom out again to make sure I don't lose anybody, you got to mobilize the fat, then you have to oxidize the fat. You have to, in other words, you have to mobilize it, then you actually have to convert it into energy. If you just mobilize it and you don't convert it into energy, you don't oxidize it, it can be returned to body fat. And many of the things that the nervous system can do is to increase the mobilization of fat, but also the oxidation of fat. Okay, so you have two opportunities to burn more fat. And both of those opportunities are governed by your nervous system, by neurons that literally send little wires that we call axons into fat and release chemicals that provide a stimulus for more of that fat to be mobilized, and then later for more of that fat to be burned up. Okay, so we could go really deep on this, but I'm not going to go much deeper than that because this isn't a biochemistry of fatty acid metabolism lecture. This is about how to burn fat using your nervous system. But remember, there's a mobilization step and then there's an oxidation step. I think any one of you, all of you should be able to internalize that. Mobilize, then oxidize. Okay? Mobilize, then oxidize. So what are these neurons that connect to fat doing? What are they releasing exactly? How do they actually increase fat mobilization, and how do they increase fat oxidation, burning of fat? Well, there are a couple of things that they release that encourage that process. And the main one that you need to know about is epinephrine, or adrenaline. The conversion of these fatty acids into ATP in the mitochondria of cells is favored by adrenaline. Okay? And adrenaline is released from two sources. Adrenaline is released from the adrenal glands, which sit atop our kidneys in our lower back. And it's also released from the so-called sympathetic nervous system, although that name is a bit of a misnomer because it has nothing to do with sympathy. It has to do with stimulating alertness and promoting action of the body. There's a big mistake in the literature that is finally being corrected among those who know. The mistake in the literature is that the adrenal glands and the release of adrenaline is what stimulates fat loss and fat oxidation. In fact, it was thought for a long time that adrenaline swimming around in your body of when you're fasted, because fasting can increase adrenaline, or when you're engaging in intense exercise, or when you're stressed, is going to promote fat oxidation. That's actually not the case. The adrenaline that stimulates fat oxidation, the burning of fat, is coming from neurons that actually connect to the fat, not hormones like adrenaline that are swimming around in your system. It's a local process. And this is very important because it means that what you do, the specific patterns of movements, and the specific environment you create that can stimulate these particular neurons to activate fat, meaning to release fat, to mobilize it, and then to burn it, is going to be a powerful lever that you can use in order to increase fat loss. So what have we said so far? We've said that you got to mobilize, you got to burn fat, and that your nervous system is in control of that process. It's not just about calorie deficit. Okay, so let's talk about how to activate the nervous system in ways that it promotes more liberation, movement, mobilization of fat, and more oxidation of fat. So one of the most powerful ways to stimulate epinephrine, which is also called adrenaline, from these neurons that connect to fat and to thereby stimulate more fat mobilization and oxidation is through movement. But I'm not talking about exercise. The type of movement that I'm referring to is extremely subtle. And some of you may be familiar with this type of movement, but I'm guessing you're probably not familiar with what I'm about to tell you, which is that shiver or shivering is a strong stimulus for the release of adrenaline, epinephrine, into fat and the increase in fat oxidation and mobilization. But shiver is not just induced by cold, and there are other subtle forms of movement that can greatly increase fat metabolism and fat loss. There was a group in England during the 1960s and 70s that discovered a pathway by which subtle forms of movement can greatly increase fat loss. This is the work of Rothwell and Stock. It's very famous in the thermogenesis literature. And I learned about this early on when I was an undergraduate. And I asked, how did they come across this? And here's how the story goes. They were aware that some people overeat and yet don't put on weight. Other people overeat even just a little bit, and they seem to accumulate extra adipose tissue. Now, this is long before all the discussions about microbiome and hormone factors, and is long before many of the hormone factors besides insulin had even been discovered. What they did was they examined people who overate and did not gain weight. And what they observed was that those people engaged in lots of subtle movement throughout the day. In other words, they were fidgeters. And that's what they called them. I'm not going to do the British accent version of fidgeters, but Rothwell and Stock were British. What they found were people that overeat but don't gain weight as a consequence. And in fact, many people who had low levels of body fat had a lot of resting tremor, not of the Parkinsonian type, but they would bounce their knee while they were sitting, when they would talk, they would engage in very angular movements. They were sort of electric. In fact, now in science, I was chuckling about this as I was diving back into this literature, because the other day I heard a wonderful lecture on a totally different topic from a colleague of mine, and we all adore him. He's over in Europe, and he's this tremendously successful scientist, so we like to poke fun at him. And every one of his movements is incredibly electric and staccato. And he's rail thin, and he eats like a horse. And so it fits very well into the discovery of Rothwell and Stock, who discovered that fidgeters, people that bounce their knee, people that have a head bob while they're listening, people that nod a lot, people that stand up and sit down a lot throughout the day, and people that pace burn anywhere from 800 to 2,500 calories more than the control group in the experiments that they looked at. And indeed, there's been a modern look into all this, and these numbers check out. That simply moving around a lot, even if those are subtle movements, greatly increases the amount of energy that you burn.